Okay, how are we doing? This is Mike Johnson here, and this is a continuation of our transformations discussion. So in this video, we're going to talk about a special type of transformation, and this actually is going to be a reflection. This is going to be a reflection, and we're going to have two main types of reflections that we're going to discuss in this video. We're going to talk about reflections across the x-axis, and then we're going to have a reflections across the y-axis. So these are two types of reflections that we're going to discuss in terms of this transformation section. So let's go ahead and get an idea of what I mean when we talk about a reflection. Let us go ahead and talk about what I mean when we talk about a reflection. So let's go ahead and look at f of x equals to the square root of x. Where square root of x is one of my favorite functions. I like it, and it's relatively easy to draw. So it's going to look something like this. And again, it is going to continue on to infinity, and it starts here at 0, 0. If it helps you, you're more than welcome to plot and use a t-chart to give an idea of what this is going to be. So if we were to use a t-chart, if x is 0, y is 0. If x is 1, the square root of 1 is in fact 1. If x is 4, I'm going to jump over to 4. We're going to have the square root of 4, which is 2. When x is 9, the square root of 9 is equal to a value of 3. So here is my point 0, 0. Here is my point 1, and this will be a value of 1, so this will be the point 1, 1. Over here, I'm going to have the point 1, 2, 3, 4. So this will give me my point 4, 2. Then all the way out here, I'll just say it's a value of 9, and this will be my value of 9, 3. So 9, 3. So we are going to have a function, and again, you can always plot points. You can always plot points if you forget what they look like. That's the nice thing about these functions. You can always plot points. So this is our function f of x equals to square root of x. So when I say I can reflect this graph, what I mean is that if I were to reflect, for example, across the y-axis, if I were to reflect across the y-axis, imagine folding your paper or turning your paper in half or rotating it and flipping it 180 degrees. So we would flip it, it would come out, and it would flip over on this side. So it would flip over on this side. So it would create a stamp. It would create a stamp or a mirror image on the opposite side of the y-axis, on the y-axis. So here, we would no longer have the point 1, 1. We would have negative 1, 1. We would have negative 4, 2. And then over here, we would have negative 9, 3. So this would be negative 9, 3. This would be negative 4, 2. It's a negative 4, 2. Negative 4, 2. And this would be negative 1, 1. So that would be an example of how we would rotate or flip across the y-axis. And in actuality, the graph of this function is going to be the square root of negative x, the square root of negative x. So that's how we would graph this, and you could actually plot points, or you could graph this on a graphing calculator to confirm your solution. Let's say that I wanted to rotate or flip or create a mirror image about this axis, the x-axis. So what I would do here is that this is me. I would have to take my paper and I would fold it in half along the x-axis. And what that would do is that would create this image. That would create this image that would look something like this. So now I would no longer have the point 1, 1. I would have the point 1, negative 1. So this would be a 1, negative 1. And then over here, at this point down here, I would have the point 4, negative 2. The point 4, negative 2. And then lastly over here, I would have the point 9, negative 3. And I would be down here. And in actuality, the graph of this function, the equation of this function is going to be f of x equals to the negation of the square root of x. So starting with my base function, f of x equals to square root of x, these can be transformed by either flipping or rotating about the x-axis or flipping or rotating about the y-axis. So let's talk about which is going to occur where. So we will say a rotation about the x-axis will occur if you negate your base function, which is the same thing as me writing if f of x equals to the negation of f of x. So this is the same thing as me saying negate the base function. So in that last example, we saw an x-axis rotation when we negated the entire square root of x. When we negated the entire square root of x. If I look at another example, f of x equals to negative x squared. This, in fact, will cause my parabola that normally opens up. So my parabola that normally opens up, and this will now flip across the x-axis and open down. So it's going to look something like that. So that negation will cause an x-axis rotation or an x-axis flip. Now let's talk about how we determine a y-axis rotation. So let us discuss a y-axis rotation. A y-axis rotation. So if we look at a y-axis rotation, we will say a y-axis rotation will occur if f of x is equal to the functional value of the negation of x. So if we negate all x's, our function will rotate about the y-axis. So going back to that square root function analysis, notice here we had a y-axis rotation when we had the square root of negative x. So in this circumstance, what we did was that we flipped this, and it no longer opened up to the right like such. This now opened to the left because we rotated it or flipped it. We flipped it about this axis. So this would be the square root of x, and this is the square root of negative x. Okay, so let's analyze one of the more, I'd say more confusing areas is the functional value of x squared. If I look at f of x equals to x squared. So notice here, this is going to be a parabola that opens up like such. So we know we're going to have a y-axis rotation, or a y-axis flip, or y-axis mirage if f of x equals to the negation of all your x variables. So if I negate my x variables, I should flip around my y-axis. So let's think about this. If I were to flip or fold this graph along the y-axis, if I were to fold along the y-axis, does everyone see how we should have a mirror image? We should have a mirror image of our function. And we do because we know that this graph, as we learned in a couple sections prior, has y-axis symmetry. So let's see what happens. Let's see what happens when I negate the variable x. So this will equal to negative x quantity squared. But when I square a negative, we're just going to get the same function back. We get the same original function back. So that means that this graph is symmetric about the y-axis, and this was actually the rule for y-axis symmetry and even functionality, that when you plug in a negative x to your function, if you get back the original, that means that you are symmetric with respect to the y-axis. And that y-axis symmetry also means that you can't really rotate it and get something different. So you will have to expect to see the exact same function. Whenever you have an even function, you will see that there will be no mirror image created because it is symmetric to the y-axis.